Welcome to Unit 9, where I'm finally going to be talking to you about how to write an introduction. These are methods that I have found have been really helpful, and I've actually based them off a couple books that I've read about how to do scientific writing. So I think they'll be really helpful for you for when you're writing your paper. It won't be the longest set of slides in the world, but it will be, I think, hopefully very informational. If you stick with this method of writing an introduction, I think it'll help you in the long run, and it'll definitely help you out for this class when you're writing your paper. So, some objectives that we'll be learning for today. We're going to be learning an effective strategy for introduction writing, which is something called and, but, therefore. And it's a way of writing your introductions so that it's consolidated, precise, and in a way that is reasonable for anyone to read, and to overall become better writers. So, I kind of went over this before, but what is an introduction? An introduction is a comprehensive background of the literature that you are presenting on, and it additionally explains the importance of your work. And what I mean by that is it explains, so we've had all this background research before, what can be overall added from my partake, or in this case, you who are adding something, the importance of your work. And then additionally, it's a place where we indicate our research questions and our hypotheses. That's going to be really important as well, that I'm going to make sure that when you write your introduction, luckily for you, you'll be writing your introduction for you turn in the final paper, and it'll tell you whether I think you are doing a good job of indicating your actual research question and hypothesis. So we're going to start off by discussing what a hourglass approach is. So for an hourglass approach, what you're going to do is you're going to start off with a broad opening statement of some sort. And you might be wondering, like, how broad should that first statement be? I'm going to be sticking with a theory called terror management theory throughout this entire um, lecture. It's not really important you know what terror management theory is. What's important to know is that we're just going off some theory that you will be doing with your paper. So what we can start off, if we take a look at our image here, we start with an opening, and you see this called an hourglass approach that we can talk about in order to make our introduction more appealing. So we start off with an opening, which is a very broad opening line that talks about your theory in general. Then we narrow it down into something called the challenge. We say, well, what is the challenge that we're facing with this theory? And what is the problem that it's not, what are some questions that it's not currently answering? Then we go into something called the action, which is still just as narrow, in which you indicate how you are going to be um, assessing that challenge for the day. Then you broaden out into your resolution, and you say, and this is how I resolve my I resolve the actual action that I'm taking. And so you might be asking yourself, how broad is that first sentence that we're going to be using in our opening? You can say something like, people are complex. Well, that's a little too broad, right? It's a little too broad. Additionally, you can say something, in this case, terror management theory is defined as, well, in my opinion, that's a little bit too specific. Now, or you can say something, the psychological conflict regarding humans' potential for reincarnation may instill self-preservation behavior that is important to consider, especially upon looking at humans' awareness of their own mortality. That is actually a pretty good defining first sentences. Or additionally, another, in my opinion, probably the best one is saying, fear and anxiety are two of the most uncomfortable emotions that humans experience. That's a great opening sentence. It's engaging, it's broad, it gets your reader interested in what's happening, and then it leads you in to start talking about what terror management theory is in this case. So following our hourglass approach from before, we work to narrow the focus of our paper as we get further along into the introduction. So the previous slide was talking about how broad your topic sentence should be. Now we're going to talk about our second paragraph. So our second paragraph really sets the stage for this narrowing. Like the case in your first paragraph, it's best to utilize a strong topic sentence in the second paragraph in order to introduce the other variables in your research. In this case, we are working to introduce the belief in reincarnation. So keep in mind, whenever you see the word, the initials TMT, I'm talking about terror management theory here. And what we're going to be doing is connecting our theory of interest. So in my case, it's terror management theory. In your case, it'll be whatever theory you're talking about. So that will be something along the lines of social comparison theory or social learning theory, either one of those or whatever yours is, and connecting it to what your variables of interest are going to be. So in this case, we're working to introduce the belief in reincarnation with the terror management theory. So let's go ahead and take a look at all of our sentences here to talk about what a good topic sentence would be. So let's look at these. It says TMT is related to the belief in reincarnation, or many studies have previously applied TMT to the domains of religion and spirituality, as TMT is highly relevant to cultural values and beliefs. Or my study will look at the relationship between TMT and reincarnation. I want us to notice that we are keeping in the first person narrative. What out of these three sentences seems like it's the best one? Well, in my opinion, it would be number 2, which is many studies have previously applied TMT to the domains of religion and spirituality, as TMT is highly relevant to cultural values and beliefs. So, what is that? Why do I think that one? Well, think about it. We're talking about terror management theory, and we are relating it to actual variables of interest. So in this case, our variables of interest are religion and spirituality. So the second sentence works best. So with this strong topic sentence, we can then begin to review the literature on TMT and religion and spirituality. In other words, you're making a case for why your research question is important before even stating the research question. So in order to actually relate everything to your variables of interest, that's when you're going to be conducting your literature review. So really, the second paragraph from the previous slide should be associated with an actual literature review. And after you review the relevant literature, then you then need to make the case for why your research is important. This is why the literature review is so crucial. You're making an argument for your work, ensuring that you're the first to look at this particular idea, unless you're doing some sort of review or replication of a study, of course. But in the case of this project, you'll be actually analyzing what is missing from the literature review. So, and why is this missing research important to conduct? So, for your third paragraph, what you can do is you can say something like, while a host of research exists regarding your theory of interest, here it's TMT, and Christianity, less is known regarding the relationship between TMT and the belief of reincarnation, thus setting you up for the missing link that you're about to contribute towards the literature. You could say things also like, no research exists regarding the relationship between TMT and reincarnation, or research is needed on TMT and reincarnation. However, I do think that the first sentence is the best way of outlining the gap in the literature. Then you're going to try and transition into the method. So really, you can kind of see what I'm pointing out at is that your introduction can be anywhere from about 3 to 5 paragraphs. But then you're going to be transitioning into the methods. So the transition paragraph is crucial as it links your review and your discussion to your methodology. You say, this is why I'm researching X, and then in your methods, this is exactly what I will do to research X. And that's the most narrow part of your hourglass in which you transition into the methods section of it. So some examples of topic sentence for your final paragraphs, you say something like the current research study works to address. I hypothesize that. I would really encourage you to put a hypothesis within this section or even stating the research question. This study will prove that. However, I want us to be very knowledgeable with the idea of prove is not exactly the best way of saying things because really we never prove things in scientific research. Or given the aforementioned literature, a closer look at the relationship between blank and blank. So really 1, 2, and 4 are really your best transition sentences into a method paragraph. So now I'm going to be talking to you about the and, but, therefore method. So many students write papers on the premise that we should be summing up many ideas together, making connections after connection. So this is well-intentioned, but really bores the readers and honestly your instructors, so me, and leads to people falling asleep during presentations, papers, etc. So instead of making a long string of connections in your paper, focus on telling a story. According to Randy Olson, which is where I'm saying that I'm getting an actual, I'm getting this from other literature. According to Randy Olson, every story can be summarized via and, but, and therefore templates. So, for example, this format builds tension and leaves readers wondering what you are going to do about the issue, i.e. the but. Providing a resolution via the therefore, which adds meaning to your research and gives a sense of conclusion to the readers. So it's a way to format paragraph and papers and stay organized. So you avoid this and, right? This is where you're just summing up the literature over and over and over again. You want to be able to tell a story, and that's where you can tell a story by using the and, but, therefore method. So for example, I kind of sum it up here pretty quickly. So I first identify what terror management theory is to the reader and how it can be applied to the belief in reincarnation. But researchers have yet to do this and it's limiting our understanding of some blanks. So that's the missing literature gap. Therefore, we will close the gaps in the literature by addressing blank. So therefore is the aspect that you are going to close the gap in the literature. And this can be done in a few paragraphs. I would say anything from 3 to 5 paragraphs. In summary, introduction provides a background on the research topic. We use an hourglass approach to write introductions. And then it's an and, but, therefore method is a helpful strategy to write an introduction. Next, we're going to be talking about probably one of my most exciting subjects, which is statistics in psychology. I am pretty big on statistics. I love it. I think it's one of the most fun things to do. Others might disagree, but what can you do? So let's just dig right into it. So our objectives for today are we're going to distinguish between descriptive, correlational, multiple variable, and inferential statistical analyses. We're going to learn what an effect size is and understand when to use particular statistics. So let's go ahead and get started with descriptive statistics. Descriptive statistics are essentially when you only have one measure that you'll be looking at. So remember how we had descriptive research before? These are the exact kind of measures that you'd be using for descriptive research, where you only have one variable of interest and you're describing one variable. So let's start off with our measures of central tendency. We have 3 measures of central tendency. That's the mode, which is the most commonly used score. So if I had a measure of 1, 3, 3, 3, 3, 3, 7, 2, 2, 5, 6, 3 would be our mode because you saw that I said 3 quite many more times than any of the other numbers. Therefore, our mode would be 3. Additionally, we have a median, which is the middlemost score of a distribution of scores. Imagine this is where you have a length of a ruler and you cut everything down up until you're at the very middle number indeed. In the options where it's an even number set of numbers and you have two numbers that are set into the middle, which say like it's a 5 and a 6, you take the middle of those two. So between a 5 and a 6 would be 5.5. Lastly, we have our mean, otherwise known as the average. This is the sum of scores divided by the number of scores. And you can see that in the equation in the upper left there, which is the sum of the scores over the total number of scores. And oftentimes I like to think of the mean as balancing a sword. If you know anything about swords, you know that the way to balance a sword is not on the middle of the sword, but rather it's on the hilt of the sword, which the hilt is where the handle is, and that'll be the balance point of the sword. So that's really the best way to, I think of, to describe the mean. Next, we're still in this kind of realm of descriptive research where we're only describing one variable, is we have measures of variability. Now there's two types of measures of variability. One of them is the variance, in which it's a computation that quantifies how spread out the data is from the mean. However, something to note about this population variance is that it's the amount of square deviations from the mean. And a square deviation means that it is however far apart something is from the mean squared, which is really hard to interpret. However, we need the variance so that we can have it for it's extremely useful in mathematical computations and statistics, so it's actually a pretty necessary part. We also have the standard deviation, which really is the same thing as the variance, but it's in a more interpretable way of looking at things. Standard deviation is the square root of the variance. It captures how far, on average, each score is from the mean value. Notice how we're talking about the mean value. We're not talking about the median or the mode. We're talking about specifically the mean. We use this because it's more interpretable. Now, whatever distance we are from the mean is the actual distance. It's not in a matter of square deviations anymore. So, however, again, we need the variance for many of these calculations. Now, I just want to point out that these are a lot of statistics that we use in psychology, but for the purposes of this class, you're not really going to be using them, but it's necessary just to know what they are. In Psych 350, you're really going to be digging deeper and actually utilizing these measures a lot more. Additionally, we can always visualize our descriptive statistics. And again, this is just one variable that we are looking at. The first one is a histogram. A histogram is otherwise known as a kind of like a frequency plot. This essentially tells you how many times a certain number shows up in a data set of some sort. So I'm going to go ahead and circle on red. This is what a histogram looks like. Next, we can look at bar plots. Bar plots essentially compare nominal categories and see how often they show up. So remember our word nominal, which is categorical? They show how much the frequency of a nominal variable, and I'm highlighting it in blue here, shows up in a data set. Lastly, we have box plots, which I'll highlight in green. A box plot shows us the minimum, the maximum, the median, which is the median is right here, circled in green again, as well as quartile 1 and quartile 3. And it additionally shows us outliers, which are indicated in the green circle here, which are areas in which these values are far out of the range of what we would expect. Next, we're going to talk about correlational analyses, in which this is where we're considering the distribution between two different variables. So remember our correlational research where we have two or more variables? These are the instances in which there are only two variables that are measured and we're comparing with one another. So I'm going to go ahead and give you a quick lesson on bivariate correlations. Bivariate meaning that there's only two variables that we're looking at. So a bivariate correlation is the association between two measured variables. Now I think we already talked about this before, but I wanted to dig a little bit deeper. Additionally, your Morling book has a lot of information on what a correlation represents and how you can talk about it. So the strength of correlation is quantified by a correlation coefficient, and we represent our correlation coefficients through the letter R. Your R, which is the correlation coefficient, ranges from -1 to +1. A +1 indicates a strong positive correlation, and you'll see that on a graph it has a strong upward rightward trend, whereas a R closer to -1 signifies a strong negative correlation. So keep in mind that these are both strong correlations with one another. It's about how close to 1, whether that be -1 or +1, that determines whether or not it's strong. Then you can also have correlations that are closer to 0, which means that there's really a weak correlation. A correlation of 0.0 indicates no correlation among the variables at all, and it's a very weak correlation. And I went ahead and kind of showed you what these correlations look like visualized as well. So as you can see, a correlation of perfect 1 is has a linear relationship that goes in upwards into the right. Whereas a 0.9 indicates that you can still kind of draw a line through it, but it's not perfectly correlated with one another. 0.5 the same, but your dots are a little bit more spread out. Whereas a 0 indicates that there's absolutely no correlation. If I were to, I can't really draw any line that would fit that data anywhere within that. Additionally, you can do all the same things, but in the negative trend, where it would be going down into the right. And it looks kind of the opposite of what you would expect of the perfect positive correlation, whereas the perfect negative correlation looks like kind of opposite. But it's still a strong correlation nonetheless. Additionally, we can talk about this concept called simple linear regression. And really, linear regression is just an extension on correlation. And really, with simple linear regression, all you're asking yourself is, what is the best fit line? You might remember from your high school algebra class in which you had a y equals mx plus b, right? You're trying to figure out what the best fit line is. M represents the slope, x represents your value of interest, and b represents the intercept. However, now we're talking about y equals a plus beta x. A is your intercept here, and I have that highlighted in green on the picture to the right, plus beta x, which represents your slope, and I have that indicated in the blue kind of arrow that's going off in a positive direction on the picture to the right, in which we're comparing the height with the body weight in the graph to the right. So y is our outcome variable, which is indicated by the y-axis. A is the intercept, which is indicated by that green circle on the graph to the right. Beta is the slope of the line, which is represented by the blue kind of whatever you call that thing, whatever the blue line is, and I have it indicated with slope. And x is the predictor variable, which is indicated on the horizontal line on the bottom. But again, whenever we're talking about simple linear regression, we're looking at the relationship between two variables specifically. Now we can talk about multiple variable analysis. This is where we're going beyond that of two variables. You're going to be learning a lot more about this in Psych 350, but I'd like to give you a very brief introduction so that when you get to Psych 350, you're not completely in the dark as to what is going on. And again, we're not going to be doing any of this math. This is just an introduction overall. Now we're going to be talking about multiple regression. So what we were talking about in the previous slides was simple linear regression. Now is a concept called multiple regression, in which we're testing for the association of two variables while controlling for another variable. And you remember from the experimental design chapter where I talked about how we can statistically control for variables? This is what I mean where we can statistically control. We're not going to get so much into the mathematics of what's going on, but essentially what's going on is when we are performing multiple regression, we're asking, how associated are x and y, so really, how correlated are x and y after I account for their correlation with other variables? So remember, regression is just an extension of correlation, and now we're able to plug in more than two variables. Additionally, we can talk about things on the predicted value of x on y. So we're able to use our variable of x to predict y. And as you can see from the Venn diagram on the right here, what we're doing is doing something called explaining variation. So we have our variable x, we have our variable x1, we have our variable x2, and we have our variable y, which we're going to consider our outcome variable, and x1 to be our predictor of interest. And it tells us that our medium shaded area here, or let's start with the light. Our light shaded area is the estimated marginal effect of our x2, so our predictor variable, that's not so much of interest on y. And we're pulling out anything that x2 explains in y. Whereas the medium shaded area is the estimated marginal effect of x1 on y. So our predictor of interest on y, we're saying how much is explained by x1, our predictor of interest alone. Then in the darkest shaded area, we're saying how much of the joint variation between y, x1, and x2. So what is being explained by x1 and x2 in the variation of y? So how is x1 and x2 explaining y? And as you can see from this estimated multiple regression approach, we're able to get a lot of information. We're able to see A, how much does x1 explain in y? B, how much does x2 explain in y? And then C, additionally, how much does x1 and x2 jointly explain in our outcome variable of y? Now again, we're not going to go through the mathematics. I'm not going to expect you to do any multiple regression in this class, but I'm just preparing you for what you'll be learning in Psych 350. And I got to be honest, this is one of the most fun things that you can be doing in psychology. And additionally, it really is extremely useful. Next, we'll be talking about analysis of variance, otherwise known as ANOVA. This is sort of like regression, what we learned in the previous slide, but it's a special case. This is where we're often using ANOVA framework within experimental study designs because we often have some sort of nominal variable that is predicting a variable of interest, and our nominal variables are oftentimes some sort of conditioned variable. So we have some sort of causative effect that is happening here. So this is where all of our independent variables, notice how I'm using the word independent variables because usually this is associated with an experimental study design to explain what is going on in the outcome variable of y. It's often used to understand the effect in an experiment, and what it does is it compares different levels of an IV to the grand mean, as you can see is happening in the image to the right, while accounting for the variance that is associated in each of our groups. So as you can see from our image to the right, it looks like mean 1 and mean 2 are slightly lower than the overall grand mean. However, they seem to be slightly the same as each other And as you can see, the variation between mean 1, which is yellow, and mean 2, which is the purple/blue kind of color, are really close to each other. However, mean 3, which is indicated in red on the image to the right, is farther apart from the mean 1 and mean 2, indicating that this group of interest is different than the rest of them, most likely. You'll additionally be learning in Psych 350 to some degree what moderation is. Moderation is when the relationship of one variable changes based on the level of another variable. So, this is actually quite a confusing topic for some people, and actually it becomes quite confusing for me as well. So, for example, the effect of stress on depression is different for people with different levels of social support, which is actually pictured to the right. And so what we're saying here is that people who have different levels of social support and different levels of stress experience depression at different rates. So therefore, if we look at our picture to the right, individuals who have high social support experience less depression even in times of high stress as compared to people that have low social support and high levels of stress. And I'm going to go ahead and kind of circle that. I'm going to go ahead and indicate that again with the red thing. So as we can see, individuals who have high levels of social support as indicated by this bold arrow to the very right. So, and additionally have high levels of stress, oftentimes have lower depression as compared to those with low levels of support. So as can be seen with the least bolded line, you can see that these individuals with high stress and low social support experience higher levels of depression as compared to their high social support counterparts. So you can kind of see in this graph what's going on where you can't talk about someone's depression level and their stress unless you know what their social support is. And really, something that I'm going to state right now, because they will remind you of this in Psych 350, is that moderation is not the combination of two variables equals more of an effect. So what that means is just because you have high levels of stress and high levels of social support does not indicate that more stress would necessarily mean you have higher levels of moderation. Moderation is essentially saying that when you group things in different ways, that people react differently to these situations. Next, we can talk about mediation. Mediation is a special case of regression in which we are able to indicate some sort of predictor is required to go through some mediator in order to experience the outcome variable of interest. So our predictor here of x it goes through our mediator variable in order to experience the outcome variable of interest. There isn't really much more to this other than the fact that what you'll be seeing is that the predictor variable will be going through the mediator to get to the outcome variable. However, in the case of mediation in psychology, oftentimes our predictor variable can still come out to the outcome variable without the use of the mediator. So let's say like 40% of the predictor variable has to go through the mediator in order to get to the outcome variable of interest, whereas the predictor variable, 60% of it can go through without the mediator variable to get to the outcome of interest. Next, we'll be talking about inferential statistics. I will have a few questions about this in the test, so make sure that you do kind of have understanding of inferential statistics. And if you don't understand it, be sure and either come to me in the Canvas chat or send me an email asking your questions about what inferential statistics are, because to be honest, there will be questions about it on the midterm. So in inferential statistics, we're talking about things of null and alternative hypothesis testing. So a null hypothesis is when you're stating that there is no effect, whereas an alternative hypothesis is when you're stating there is an effect. So essentially all you're saying is that in the null hypothesis, I'm saying that I've theorized that there is no effect in the accounting of therapy on people's depression levels, whereas the alternative hypothesis says quite the opposite, in which says there is some sort of effect that is associated with therapy and the outcome of depression. Now, I'm sure many of you have heard of p-values before. What a p-value is saying is that it's the percent chance that you attain the effect you got given the null hypothesis is true. So for example, a p-value of equal to 0.05 says that there is a 5% chance that if we got the effect we saw, if the null hypothesis was true. So let me say that again. A p-value of 0.05 says that there is a 5% chance that we got the effect we saw if the null hypothesis was true, which is stating that if there really was no effect, there's a 5% chance that we got this effect from that. Now, I really do, for the midterm, I really advise that you memorize what a p-value is so that you can get it correctly on the midterm. So this is a really important slide for you on the midterm. And if I could just find my cursor, there it goes. Inferential statistics are used to test and determine statistical significance. There's three types of inferential statistics. These are chi-squared test, t-test, and f-test. A chi-square test, represented by this kind of Greek letter chi, which looks like an x squared, tests the relationship between two categorical variables. A t-test tests the relationship between two group means, which means that there's some sort of categorical variable and an outcome variable of continuous variable. So it's a nominal variable for the predictor variable, and the outcome variable is continuous. An f-test tests the relationship between multiple group means. So really, it's an extension on the t-test. And what I mean by it's an extension on the t-test is that it means that there are multiple your nominal categories have multiple groups that are more than two, so it has three or more groups in it, and you're testing the means between those groups. So let's start off talking about what a chi-square test is. And again, I'm showing you these equations, but there's not really a use for them right now in this course, but I'd like you to be exposed to them before we get to Psych 350. So a chi-square is used when all analyzable variables are categorical. We compare the obtained value to a chi-square distribution table to determine the significance. And you can look up what a chi-square distribution table is from Google. You might have one in the back of your book. I'm not too sure, but overall you can find these on Google's. And from here, you can obtain a p-value of statistical significance. Next, we can use the t-test in which we compare the value of two means. And again, I show you this this equation, but we're not going to be utilizing it at all in this class. But it is a useful equation. In fact, even for next semester or whenever you take Psych 350, you won't be utilizing this equation per se, but you'll be utilizing a program called R that will utilize this equation and do the math for you. But this is what's going on in the background. So in the t-test, we compare the obtained value to a t-distribution table. So you're noticing a theme here that there's some sort of distribution table to determine some sort of significance. And from here, you can obtain a p-value for statistical significance. And then lastly, we have the f-test, in which we use to compare the values of 3 or more means. We then compare the obtained value to an f-distribution table to determine significance. So from here, you can obtain the p-value from statistical significance. So really, the main thing I want you to get out of the chi-square, the t-test, and the f-test is exactly what they're doing. A chi-square is comparing nominal variables of interest with each other. A t-test is comparing specifically two group means, whereas an f-test is comparing 3 or more means. So if I ever ask you, I have a test with that is comparing 3 or more means, what test should I use? You should be saying it's an f-test. If I'm saying that you're comparing a group of 2 means specifically, then you should be using a t-test. Lastly, we'll be discussing what effect sizes are. And the reason I wanted to bring up what effect sizes are is because when you get reading through your literature, I think you'll be finding quite oftentimes that there are effect sizes that are reported in your papers of interest. So when you read through the results, you'll be like, oh, I understand what an effect size is. Hopefully after you read through this, after you listen to this lecture. So what is an effect size? Effect size is a quantitative measure of magnitude or strength, magnitude is the same as strength, of a phenomenon. What it does is it emphasizes the size of the relationship. There are many types of effect sizes, but we'll only be learning about 2. And it just so happens one of them you actually already know of that we explained earlier in these slides. So the 2 effect sizes that we'll be talking about are R and D. These are otherwise known as your R, which we learned earlier, is a correlation, and Cohen's D, which is a comparison of two mean values. So you already know what a correlation is, so I don't necessarily have to go through it anymore. However, what I will say is what we're looking at with effect sizes is the actual relative value that they take on. For a correlation, what we're trying to determine here is what is a small, a medium, or a large correlation. So in this case, a small correlation is a correlation that takes on a value of 0.10 or lower. A medium correlation is those that take on a value of around 0.30, and a large correlation is one that takes on a value of 0.50. We can additionally talk about Cohen's d, in which we're analyzing the difference between 2 groups. This indicates how much variance is shared between the groups and how different their means are. So, really, the main thing you need to know about Cohen's d is that it ranges from 0 to just about infinity, in which a higher score indicates a larger difference between groups. So, as we can see from the picture on the right, and again, I show you the equation with the understanding that we don't necessarily need to memorize the equation or know about it. I just want you to be aware that there is an equation behind it. But I really like the visualizations of this. So what we're seeing here in the picture to the right with the with the green and the blue distributions is what we're seeing is that there's a difference between these 2 distributions, and the differences between them is normalized as D, or otherwise known as Cohen's d. So, as we can highlight with the red here, sorry, let me get my red marker here. The difference from here to here is known as Cohen's d, as you can see that I'm circling here. The difference between these 2 values is known as Cohen's d, and all that is the differences between mean 1 and mean 2 while taking into account the variance that each of them contain. And really, what you need to know from here is that if you get a Cohen's d value of less than 0.20, that's considered a negligible Cohen's d value. Whereas a Cohen's d value of 0.2 to 0.49 is considered a small Cohen's d value, and a value from 0.50 to 0.79 is considered a median value, and keeping in mind that the larger these are, the farther away that those means are from each other. And additionally, a Cohen's d of greater than 0.80 is considered large. And remember, so 0.80, what that really means, and I guess I'll tell you the exact definition here, but what that means is that the means differ by 0.8 of a standard deviation from one another. So you remember what a standard deviation was from the beginning of these slides, in which it is the variation that you are from the mean in standardized units. A 0.80 Cohen's d is saying that mean 1 is different from mean 2 by 0.8 deviation units. So less than 1 deviation unit is what it's saying. Next we have R, which I'm not going to dig too deep into because we already did, but this is essentially measures the strength of association between two continuous variables. It ranges from -1 to +1. However, the main thing to pick up from here is that anything less than 0.1, -1, or +0.1, anything less than that is considered a weak correlation, keeping in mind that that's getting close to 0 of no correlation. Anything between a 0.30 to a 0.49, positive or negative, is considered a medium correlation, and anything greater than a positive or negative 0.50 is considered a strong correlation, with the understanding that these values range from -1 to 1, and they can't get any higher or lower. If you have a value any higher than -1 or +1, then you did something wrong in your math. So what the main takeaway from effect sizes that I'd like you to have is that the larger the effect size, the better you're doing at describing some sort of association or difference between groups. So in Cohen's d, what you're doing is describing the difference between two means. Whereas R, or the correlation, you're describing the association between two continuous variables. So, in summary, I know that that was a very quick rundown of the statistics that you'll be learning about later. I just want you to know that many statistical analyses exist in the behavioral sciences. And I also want you to know that if you had a hard time understanding some parts of this lecture, that's okay. You're not expected to know really big differences, big things about these statistical analyses. However, I do just want you to be aware of them. In summary, additionally, effect sizes measure the strength of some sort of relationship or the differences between a relationship. And additionally, each analysis that we covered in this lecture has powerful abilities to help provide evidence for a hypothesis.